Right now we're running at about a 10 volt level from the alternator, about a 7.5 volt field, and we're configured the system now with two secondaries above and below the 266 primary system. For loading on the top coil, we've chosen 3 incandescent bulbs. For loading on the bottom coil, we've chosen a neon that uses a magnet to decrease its firing range so that we can get a better discharge. The method for using the magnet is simply to attach the black wire there, routes the potential going into the bulb to the plate on the bottom of the magnet, and the magnet itself does something to enable the neon discharge to easily assume itself. Now then, for the bottom coil. These are 2.4 Henry coils. We have 2 meters. Those are the red meters. Because of the sporadic nature of the neon discharge, the bottom left meter fluctuating quite a bit between 5 to 3 milliamps, just seen it go to 10, is taken out of the circulation of some 40 milliamps on the bottom coil. Conversely, on the top discharge of the 3 incandescent bulbs in series across the top coil, we have a more tamed down version of what's going on. And we can see that there's some 60 some milliamps in the center meter, up to 70 milliamps, and the bulbs are taking about 40 milliamps of current out. Now for the input conditions. On stator line 1-3 to the left and stator 2-3 to the right, most of the current is taken in through 2 stator lines, and the middle stator line is taking practically no current. On the left 2 meters shows the effective input of the primary to the bottom secondary, and we have 12.5 volts fluctuating greatly and some 1.7 amps. The middle coil layer, going to the middle of the primary, does serve a purpose, but for now we have to regard that as a wasted amount of energy, and that's consuming 10.3, fluctuating 10 amps and 1.4 amps. And finally, phase 3, then, with the meter to the extreme right, showing some 10.5 to 11 volts and some 4.2 amps of circulation on that top layer. That's the power input for the incandescent bulb part of it, which we see here now. Every 70, it's showing 70 milliamps of circulation. For these coils, every milliamp of circulation is equivalent to 7 volts. So we can say there 70 times 7